All right, section 4.3 starts on page 145, and this section and the next one you're going to learn is proving that triangles are congruent given information about their sides. So on this page 165, you want to take notes of three really important theorems. The first one is the side angle side congruence criterion. And what it is saying is if we have two sides of a triangle and the included angle, or take note that included angle just means the angle between those two sides. If we know that they are congruent, then the triangles are congruent. So look at this example. We've got a side, an angle, another side, and then this angle between them. Since we know that those red tick marks tell me that these two sides are congruent, the blue tick mark tells me that those two sides are congruent, and we know that those two angles are congruent, then with just the information that's given there, we can say everything about those triangles are congruent. So that is side, angle, side, and we abbreviate that SAS. Another really important theorem is just that corresponding parts, this is going to be a mouthful, but you guys got this. Corresponding parts of congruent triangles are congruent. And you're like, whoa. All that means is if you know the triangles are congruent, then their corresponding sides are congruent and their corresponding angles are congruent. So just a little example is if you look at these two triangles, angle B corresponds with angle Y. So if they're telling us that the two triangles are congruent, then we know that those two angles are congruent, and so forth. Their side lengths are congruent to each other, and their angles are congruent to the corresponding part. So like this side AC is congruent to this side XZ, and so on. The last other really important thing for this section is going to be the side congruence criterion, which literally just means if we know the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles must be congruent, which kind of makes sense. Like if all the side lengths are exactly the same, then the triangles are exactly the same. Take notes of that, and then let's jump to example 2. We're going to review some proofs using these theorems. All right, here we go. It's been a minute since we've done proofs, so let's go over first, before we even read the problem, what a proof is. It's a list of statements and the reason you can make that statement that can draw you to a conclusion. They usually give you information and tell you what conclusion you're trying to reach. So let's look at this problem. We are given that AB is parallel to CD. Okay, good. That's what these arrows mean. They're parallel. And it's also telling us that AB is congruent to CD. Good. Their side lengths are the same. Probably going to use that. We want to show that angle B is congruent to angle D. All right. So let's start thinking about how can we do that. We're going to have to imagine these kind of as two separate triangles. Like we've got this one down here and this one. They just happen to share this side, like this side is actually the same. And we're going to try and prove that those two angles are congruent. All right. They told us that those two lines are parallel, and this is where we're going to come back to what we were learning about parallel lines cut by a transversal. So I'm going to draw this out so you guys can imagine and you can visualize this. But if we draw these out to extend this, does that help you visualize something? If we know that these lines are parallel, think, what do we know about those angles in the middle? And can we use that information? So that's going to be where we're going with that. You kind of remember to start with what they give you, and then what can we draw from that that then can lead us to our conclusion, to prove that angle B is congruent to angle D. Now I'm going to erase that, but you guys in your book can keep those really dark lines. I just know we can't see the figure if I have them. Okay, so let's get started. Remember that statements, the first one is always what they give you. So I'm going to go ahead and just fill in. I know my first reason is going to be, hey, I was given this information. So let's see, what information are we given? We're given that AB is parallel to CD and that AB is congruent to CD. We have to state that, like, hey, we know this, and now let's work from there. Okay, here we go. Statement number 2. Try to think, now what did we just discover that could be really important knowing that those lines are parallel? Well, knowing that those lines are parallel, we know that angle BAC is going to be congruent to angle DCA, those two angles. Why are they congruent? Do you guys remember the reason why? They're alternate interior angles. Remember that? That's going to come back up. So let's write that out. I'll leave it in blue because those two things go together. We can know that angle BAC is congruent to angle DCA because they are alternate interior angles. And that comes from knowing that those two lines are parallel. If we didn't know that, we couldn't say that for sure. But now that we do, we know that those two lines are parallel, and therefore we know those two angles are congruent. Okay. So now let's look. We do not know that these angles are congruent, so I'm going to erase that like we don't know that. That's what we're trying to prove. Right now, all we've got is we know that this side is congruent to this side, and we know that those two angles are congruent. Well, thinking ahead, we're applying this side angle side congruence. So that means we're going to need two sides with an angle in between to do that. We have one side of each triangle. We know that that's congruent. We know angles are congruent. And so we need to establish that this segment is congruent. And you're looking at it and you're like, well, duh, it's congruent. It's the same segment. But we're going to formally establish this. That's going to be our third statement, that AC is congruent to AC. And you're like, well, duh, it's the same. We're just formally writing that down because, again, we're trying to prove that these two triangles that are created here are congruent. So if we were to draw them separately and they weren't truly connected, I didn't do that perfectly. We want to establish that these two sides are congruent, and that's what we're doing in this step. We're just formally writing that because, again, a proof has to be very straightforward, very formal. I know this because of this. I know that because of that. So the technical reason why these two are congruent is just the reflexive property of congruence, aka it's the same thing. It's congruent. But we write reflexive property of congruence. So you guys take note of that. Like, we know that that segment is exactly the same, and now we're formally calling it. I'm going to write it. All right, look at what we got. Now we formally have decided, okay, we know these two sides are congruent. We know this side's congruent. We know the angles in between them are congruent. So we can say we've proved now that triangle, let me change colors. This is important. Triangle ABC is congruent to a triangle CDA. We can formally establish that these two triangles are congruent. This should be a 3. Because of our side angle side congruence criterion. And you can literally just write SAS, side angle side. We know a side, we know an angle, we know another side is congruent to a side, an angle, and another side. And therefore, those two triangles have to be exactly the same. They are congruent, which will lead us right up to our last statement. Because remember, what are we trying to prove? Well, we're trying to prove that angle B and angle D are congruent. And that's where that corresponding parts theorem comes in. Once you've established that the two triangles are congruent, they're exactly the same, we know that their corresponding parts must be the same. So angle B has to be congruent to angle D because of the corresponding parts of congruent triangles are congruent theorem. AKA, once we know that the triangles are equal, every corresponding part is also congruent and equal. And there's a little review of proofs using this congruence criterion. Let's jump to another example and think more about those different congruence criterions. We're not going to do example 3. We're going to go to example 4. And example 4 just has us determine congruent triangles. This is going to be a very common thing you see with these is, hey, given this information, are these triangles congruent? So let's look at them. Part A says, is triangle STU congruent to triangle XYZ? And then explain. So now you need to analyze this triangle and determine, hey, are they congruent? And so if we look at it, we can see that we've got two congruent sides and their angle in between them is congruent. So we were learning a theorem that tells us if we have a side with the included angle that they're congruent. So our answer here would be yes. And if we were to explain it, we have, you don't have to use formal words, but we have two sides that are congruent with, I'm going to abbreviate, the included angle. Awesome. Let's look at the next one. It kind of already sets us up. It says, is any additional information needed to show triangle DEF is concurrent to triangle GHJ by side angle side? So it's saying, hey, use this side angle side theorem. So let's look at what we've got first. We've got DEF gives us an angle, then a side, and GHJ gives us an angle and then a side and a side. Well, that is not side angle side, what we're trying to work with right here, because the angle is not between the two sides. Side angle side means that you need the congruent angle to be included between those two congruent sides. And here we can see that this included, or this congruent angle, is not between the two sides. So that is the information we would actually need. We would need to know that angle F is congruent to angle J. We would need to know that included angle in order to determine that these triangles are congruent. What we have right now isn't sufficient. We can't say for sure. We don't know enough. So if it says, is there any additional information we need? Yes, there is. We need the included angle. If we had that, then we could say they're congruent. But right now we don't have that. We do not know for sure if these are congruent. All right, you guys, this is what section 4.3 is about, using, really 100% just using these three theorems. You know, side angle side and side side side. And then corresponding parts just means once you know they're congruent, all of the corresponding angles and sides are congruent.